So I mean, for some of the folks kind of more kind of new to some of the materials space, like, I mean, let's start kind of basic. So, I mean, you threw out the word combustible dust. And so maybe we just kind of start there, because I think a lot of the work you do is mostly in the metal space, but there are polymer powders and things out there. But kind of when you think of kind of some of these early hazards or kind of big definitions, kind of what do you mean by combustible dust?
So combustible dust is basically when you get a dust or a powder, you get it small enough in terms of particle size where you can actually make it explode. And there's a lot of things you need to do that. I mean, you need to get the cloud in the right concentration. You need to hit it with the right ignition source. And if you do that, you're going to have a deflagration, which is like a combination of you'll first have a pressure wave come out and then a fireball come behind it. Or you can actually get an explosion where you actually burst the container open, or potentially a flash fire, which is that whoosh fireball you ever hear everybody talk about. That's 3 seconds and it just whooshes itself out. But that term combustible dust has been around for a while. Most people are aware of it, especially people like that work in food and wood. Some people aren't. I mean, I still shock some people, and I don't know how, when I tell them that flour is combustible. The stuff you buy at the store, you can actually take and blow it up at home. And please don't do that, but you can. Sugar, you could do that with sugar, grain, dog food. All this dust is explosive. If you
Yeah,
get
did
it
they
the
have
right
some like
concentration.
concert issues, right? Like in Asia a few years ago, right? With
Yeah,
some like those big dust
cornstarch.
festivals. Okay,
It was
yeah.
colored cornstarch is what caused it. Yeah. So, and then wood, I mean, the wood industry is very familiar with this. It doesn't matter what species. You get it fine enough, even sawdust, you will get fires and explosions from it. The 3D printing people, it's a relatively new type of thing because I don't think anybody really thought of it. But you can primarily break the combustible dust for AM down to two different categories. You have your metals and you have your polymer slash plastics. Um, Now, your spooled plastic stuff, that's not a combustible dust concern unless you're going to shred it or regrind it. And so far, I haven't seen anybody do that. I'm positive eventually they will, just like they do for plastic bottles, like Gatorade bottles. The rejects they regrind those, and that's where they have their dust problem. Um, but so like the polymers, for example, your stuff like PA12, PA11, PA2200, all these different formulations for those polymers, those have all been shown and tested to be explosive. Um, when you get into the metal side, there's three of the most common that you get into. Number one is titanium. Whether it be Ti 64, I have a lot of people using now Ti 642. I even have this new one, Ti FE, that one of my clients is using. Titanium is really titanium. They don't really change that much, just you put more of it in there. But all of those have been proven explosive. Your aluminums, so you're like your ALSI 10s, your F357s, all of those have been shown to be explosive. And then you get into your iron powders. So like I know Praxair makes a lot of this iron stuff. Not to pick on them, but yeah, I mean, basically, so those three. Now, I do have a couple of exotic clients out there that are using zirconium, which is also explosive, and I always say it wrong, but niobium. I always say neobium because I think I'm in the Matrix or something. But yeah, basically, those two are also explosive. And then I have a couple of clients that have told me they were going to be brave, but they didn't go brave to use tantalum or magnesium. Now, if you're going to 3D print with those are definitely explosive, especially magnesium. But most of the metals out there are going to be explosive for the most part. The stuff that won't would be like your stainless steels. Those aren't explosive. So, there's a few other ones out there, but stainless is the one I'm running into a lot. That you could test that. And we haven't seen that come back explosive except in very rare cases.
Even
So
at small particle size?
even at small particle size, it's something to do with the chromium
Mm.
in stainless that's preventing it from being explosive. Because the same thing happens with cobalt chrome. It's not explosive either.
Interesting. So it's not just a definition of, hey, if it's under 500 microns or something like that, kind of consider it combustible. If you do the explosion, or like there's ASTM tests, right? Like that you can do.
Yeah,
that
there's an
define.
ASTM test you could do. it's ASTM 1226, but for the most part, these powders have been tested to death. And one of the nice things for AM for the people is that you don't really need to retest them because you're not really doing anything with them. You're taking a 40 micron powder and put it into a powder bed printer. So you can use testing data from another facility because it's representative, or you can use it from the powder manufacturer if they did it. Sometimes they do their own testing. But yeah, I mean, typically NFPA throws a size out there of 500 microns, like you mentioned, which is about the consistency of sand, give or take. The smaller the particle size, the more explosive it is. So most of the metal powders out there are 75 microns or less, which is about powdered sugar consistency. Those start to get pretty explosive, but even with metals, though, the KST, which is how explosive it is, that value, it doesn't get that high. In fact, a lot of the stuff I deal with on the titanium alloys and aluminum alloys, flour and wood are more explosive than those. That's not to say that the hazard's not there. Don't get me wrong, but there's a lot of reasons for that. The primary one is oxidation. Those metals oxidize pretty fast, and the faster they oxidize, the less explosive they are. Like you can get iron dust, true iron dust, to explode. You make it into rust. I don't care what you do to it; it's not going to explode. So yeah. So there is a difference there. So metals are unique in that perspective, but a lot of times, and people don't believe this, that the polymers in plastic are actually more explosive than the metals. So sometimes their KST values are double what the metals are.
Be sure to check out our website, www.3degreescompany.com, for more content.